Good morning. On behalf of CGI.br and NIC.br, we wish you all a wonderful day. All our greetings to you who are here physically and those who are following us at the internet. This is our 12th forum. To start today's activities, we have two videos that will explain in a summarized way what CGI.br is and NIC.br is and what our research center does. Have you imagined if you did not have a right to freedom of expression respected, if your private data would be disclosed with no authorization, or if you had your navigation filtered due to business interests? Privacy, neutrality of the network are key to the internet, and these are just some of the 10 principles that are guided by CGI.br, which promotes for over 20 years internet in this country. Thanks to it, you have constant innovation, guidelines, and safety. All of that done in a transparent, democratic way. The committee is composed by members representing the whole society. Like that, decisions are made throughout dialogue with the participation of all members until they reach a consensus. The Brazilian model of governance became a reference throughout the world, CGI.br, for a better internet in Brazil. When you register a domain .br, you are collaborating to improve internet in Brazil. Each domain which uses .br is registered by NIC.br, a new center of information and coordination of .br. In addition of register of names and domains, invests on safety incidents, projects on technology, researches which show indicators about the use of technology, information and communication, implementation of IX, local at the web, and global development projects, and much more. All of that because NIC.br is a private company with no profits, which maintains a register of a domain is stable, safe, and reliable. And part of what you pay for your domain is devoted on infrastructure investments. All this innovation, technology, state-of-art safety, infrastructure is just possible because you have a .br domain. NIC.br, always after the best to our internet. Let me remind you that detailed information about our projects and actions are available at the website nic.br, cgi.br. Now we have our sponsor time with the Abranet video, Brazilian Association of Internet. How much can you take in one day? 24 hours, 1,440 minutes, or 86,000 seconds, 864,000 decims. Time to go home, to go to bed, good evening, until the internet appeared and changed everything. The sound of the modem for the connection providers, news portal Abranet. Letters disappear, emails show up. Communication is instantaneous. There is a new vocabulary. Internet is recreated. New sites, new portals, banks, supermarkets, stores, everything online. No one wants to waste time. We have internet celebrities. People, they complain, they share, bank transactions increase. Time speeds up. What can you fit in one day? Well, today more than yesterday and less than tomorrow. I'd like to thank all our sponsors that with this action they show commitment with the development of internet in Brazil when they support our initiatives to expand the discussions. throughout all topics address internet. We'd like to thank all Abranet, Google, Cisco, TEDx Screen, Cyborg, EPS Finizar, Entity Communications, and GlobeNet, Facebook, Angola Cables, Equinix, UPX Technologies, Telxus, and Eluate. Thank you so much. Next, I'd like to invite Hugo Salgado, who is a software engineer with the presentation DNS Flag DI, the end of the temporary patches for NDS. Have a wonderful event. Thank you.
Okay, bom dia. Hola a todos. Em primeiro lugar, eu gostaria de pedir vocês.
Good morning. First of all, I'd like to apologize for not being able to speak Portuguese. Unfortunately, my Spanish is even worse than my Portuguese.
My talk is about the DNS Flag Day campaign. I'm Hugo Salgado from NIC.br, the .cl CCTLD registry, and I'm going to show you what is it about, why it matters, and how it affects us. This talk was presented in the LACNOC meeting this year in Rosario, Argentina, and in the OARC DNS meeting in Amsterdam, was made with the collaboration of Sebastian Castro from Internet NZ, and I want to give a special thanks to Petr Spasek from NIC.cz, who maintains the official website and some of the tools. Okay, so what's the DNS Flag Day? It's a campaign driven by the four main providers of DNS resolution software that are there: bind, unbound, power DNS, and cannot. And backed by some of the main public DNS resolution service providers like Google, Quad9, and Cloudflare, that aims for a change in the way the DNS resolution works that can have direct consequences for current domain names around the world. So if you're going to leave this presentation with only 2 points in your mind about the DNS Flag Day, these are: one is a worldwide campaign, and two can cause the death of certain domain names. But this is for a better internet. So, what's the problem? The key is eDNS, the extensions of the original DNS specifications that are far from new. As most of you already know, the DNS is one of the oldest protocols in Internet, with its foundational RFCs being published in 1987, 40 years ago. The original DNS had a limit of 512 bytes per packet and very few space for new options. So 30 years ago, there was a major advance in DNS with the standardization of a way of extending the original DNS, the eDNS protocol. These new options were backward compatible, meaning that you could coexist with the original DNS, but deploy new features at the same time. Thanks to eDNS, these new extensions allowed many improvements to DNS and created an ecosystem about it. One of the most important is allowing more than 512 bytes per message, a mechanism that allows many techniques today like SPF with TXT messaging, load balancing with multiple A and quad A records, etc. But more than size, these extensions allows new techniques such as DNSSEC, the security extension to the to DNS. And there we have a lot more of new techniques and improvements. So, what's the problem? This deployment of the EDNS protocol has lasted more than 30 years. In the first years, the resolvers had to create some workarounds to be able to resolve certain domain names that were served by all DNS authoritative software, which lacked support for EDNS. But these workarounds had been there for 30 years, and several not compliant authoritative servers never solved its problems because, hey, it worked. But worked because of the excessive robustness of DNS. The problem is that after 30 years, these workarounds causes many problems to resolvers, like code complexity, delays, and it takes a lot of effort to evolve to new techniques. So now it's time to stop doing workarounds and let the pain be suffered by the ones who deserve it. This removal of workarounds has to be made in a coordinated way because no one wants to be the one who forces standards and let bad domain names die and letting your competitors the perceived advantage of being able to resolve those domains. So the main software developers agreed on a date for releasing its updates without workarounds. So after this date, all the updated or new installed releases will have no support for workarounds, letting bad domain names die without resolution. Also, the most famous public DNS resolution services will start to force EDNS resolution too, like the famous 8888 and 9999, 1111, etc. Google, Quad9, Cloudflare. Now, some data. How many domains will be affected? We measured several top-level domains with a tool developed by ISC, the ones that make bind, and NIC.cz. We can start with the zone of a TLD and then send some special craft queries to detect EDNS compliance. Here are the first ones, the first TLDs we analyzed, but now we have several more from LAC-TLD region that are being analyzed since 2 months ago. These are the tools we used in our study. The first one gives many details, not only for EDNS, but several other standard metrics. But for this study, we focused only on the EDNS one. The second tool allows some performance enhancement to allow batch processing and send the test to several domain names at the same time. The numbers. The numbers are very similar in CCTLD's levels, all being around 1% of domain names with serious problems. This 1% of domain names will be unresolvable after the DNS flag day. Because of its name servers have problems that will cause server fail for its domains. In the .arpa reverse zone, we have a worse percentage of failures, but by the characteristic of reverse zones, we know they're more concentrated in less name servers. In this case, we identified only 3 name servers being the culprit of 23% of failures. In the forward zones, there's more diversity of name servers, and so it's more difficult to correct. Thanks to registro.br, who analyzed the .com.br names, we also have the figure of 0.72% of domain names which could be dead after the DNS flag day. I will not dive in many details for these slides, but here we have an example of the cascading of the tests we apply for each name server. This diagram shows that if we fail in one of the tests above, there's no sense on testing the categories below. But here you can see there's like 15 or 20 tests that try every feature of the EDNS protocol. Here we have a comparison between several ccTLDs and the root servers. Root servers are good as a base comparison because they are fully compliant. And we have here the comparison with the original ccTLDs that we tried. As an example, here's one of the tests. Here we send a specific query, a valid query towards a name server, and we wait for an answer having certain fields so we can detect anomalies or lack of an answer. This is to test the basic DNS protocol. Here we have another one comparing DNS with the EDNS version 0. And here we have more problems. Also, we only have EDNS version 0 for the moment, but there are already some conversations on moving to EDNS version 1. Any EDNS compliant server should be capable of answer to EDNS version 0 queries and reject with the right answer to the non-existent DNS version 1 queries. One thing that is important to note is that EDNS compliance don't force to implement EDNS at all. There are actually error codes for the DNS servers which don't want to implement EDNS, which is a serve fail error code or a form error code. The servers have and always had a mean to signal lack of support for EDNS. And these answers are completely right. The only wrong answer is not answer at all, or answer something unexpected by the protocol. This test is for DNSSEC compliance with the DNSSEC OK opcode in the EDNS headers options. Sorry. This is a more complicated query with a lot of EDNS options, subnet and cookie. This is the more complete query that we send. Also, we compared IPv4 versus IPv6 answers, looking for differences by protocol. And actually, we had some observable differences, and we are digging in to have more information. Also, we're doing these measurements in a monthly basis to have data on the evolution of the space. We have measurements from October and since today. to today. But in summary, 1% of errors, easy to fix. In .cl, we have a campaign contacting the top ISPs and hosting companies with major problems. But it's not easy to contact the right people and to get to the administrators. So then our next step was to send an email campaign to the current domain name holders to alert them of the problem with their domain names and have them as customers to press their hosting and DNS providers. So, how can I check my domain name? Very easy. There's one web tool that anyone can use in dnsflagday.net site, which looked like this. Here we write our domain name in the box, press the test button, and wait a few seconds. This JavaScript sends the same test we showed in the previous slide to the ENS of the domain name and gives a resume of the results with a graphical sign. Fatal error is where all the name servers were not compliant, meaning that this domain name will be unresolvable after February 1st. There is a green icon too when all the name servers were okay, and a yellow one when some of them failed, meaning that you could expect a slow resolution. Also for real hackers and sysadmins, there is an expert tool that gives a lot of detail, including each individual test that failed. This one. This tool can also be installed locally, so you can run tests in your own network with confidence. Here we see each test result individually, and a command line, I don't know if it's visible, a command line to repeat the queries with the expected right answer. The interface is not so friendly, and the test descriptions are a bit harsh, but there's a link with, to the relevant RFC with the protocol basis for each one of them. Finally, how can I correct the errors? Two main points. Use a modern DNS software and avoid putting an inspecting device in front of it. Having a firewall or a deep packet inspector on the front of a DNS server is a recipe for problems. The consensus is to let the DNS server software to answer all the DNS queries, not only for compliance, but also for performance. Many of the bottlenecks of traffic with DNS DOS attacks are with the middle boxes that are incapable to bear with many packets per second, but DNS software can cope with it. In our experience solving several problems with companies, there's an 80% of chance of having a firewall dropping certain right queries, so the DNS server never receives them and the resolver never get an answer. So use a modern implementation, fix your firewall rules, and retest. A future work. We're committed to repeat our analysis as long as the DNS flag day occurs and afterwards. Each CCLTLD has its own campaigns in its community to reach out and alert its domain name owners. We hope to have a pleasant DNS flag day in spite of that last phrase there. So that's all. Muito obrigado. You can use Portuguese for your questions or comments. I think I can handle the slow spoken Portuguese. Thank you.
Perguntas para o Hugo, pessoal?
Any questions to Hugo? Hello, my name is Douglas Fisher. I am quite curious with your presentation, but I have a question about the approach. What are the affected DNSs? Authoritative, exclusively, recursive, both? Which ones? Which one should be treated specifically?
The authoritative servers that need to be compliant. The change will be in the resolvers in that side, but the ones that need to be corrected are the authoritative ones.
Ok.
Yeah.
Thank you.
And this tool allows you to test it with a resolver that gives the details.
A pergunta também.
I asked that question regarding the difficulty you mentioned, how to approach network managers to correct that. If it's difficult to get closer to those that care about authoritative, let alone the recursive, which are almost impossible to be reached. Thank you. Any other questions? We still have time. I would like to make a comment, Hugo. Actually, it's a comment to Douglas, who has asked the question. The DNS flag day, as Hugo said, they will remove the code of recursive ones. So, in fact, once companies and ISPs update their recursive ones from 1st February, the new softwares will no longer have the workarounds to live up with those problematic or troublesome authoritative. So, those campaigns right now, they aim to notify those domain names with those problems authoritative servers, as those domains will no longer work once the softwares are updated. February 1st is a date about the new releases of recursive servers. But those who have problems in the authoritative server will not have that interrupted immediately, but will start facing some resolution problems. As Hugo said, several CCTLDs will notify their clients with problems. Similarly, the register BR in Brazil.
Rubens Kiel.
I am Ruben Skill from NIC.br. I'd like to report my experience and comment about networks with problems in the authoritative and ENDS with two large content providers. One of them that was in the category that, well, it's going to become a bit slower. After a few minutes that was solved. However, with the other one that is in the category you will die on February 1st, they did not do anything yet. So we probably have a Darwin moment by February 1st, and we'll see those who care and may survive and those who do not care and will die.
It's working now. You don't need to fix it. So we have to wait to the moment with problems. Okay, thank you.
Mais alguém? Alguma pergunta? Vamos agradecer o Hugo.
So, as there are no more questions, thank you so much, Hugo, for your time and participation.
Pessoal, só para avisar, a gente vai ter mais...
Let me remind you that we'll have another presentation in English, so please do not refrain from getting your headsets. You just outside the door, you may get your headset. Now we have Ed Lewis from ICANN that will talk about Raiz rollover.
Good morning. Thanks to this, I knew I was speaking next. First, I'd like to thank you for the opportunity to speak about a project that we've been running for the past half a decade. I'll keep it. I need for the questions. Sorry. For about half a decade. And I wanted to talk a little bit about what we've been learning in the process of doing the project as opposed to going through a standard status report for what we're doing. The last bullet in Hugo's slide was watch the world burn on February 1st, right? We tried to burn the world in October and we failed, so it's your turn next. So I'll leave it with that. All right, so the KSK rollover. I'm not sure if everyone here is familiar with DNSSEC or not. I'm not really going to describe DNSSEC, but this is an operation within the DNS security extensions. Involves changing the key that we use in all of the validations. So for the talk, I'm going to give you a little bit about where the project is, a little bit of status, but not too much of that. But then I want to go into some of the observations about what we're experiencing in running this project. We haven't produced lessons learned yet because, quite frankly, we're not quite done, but we're going to do one soon anyway. And then something surprising about Brazil that came up in the last couple of months. For those of you who are not familiar with the KSK rollover, and first of all, I want to thank Frederico Neves for speaking about this before in GTER. I think it was last year or the year before. You gave a few talks, and Carlos Martinez has talked about this in LACNIC area. So it's been brought up here by local representatives who work with us on the key. But I know I haven't been to South America to talk about this before. But the idea here is we have a key, which is running a cryptographic key that we use for security of the DNS. Not everyone relies on it, but many people do. We have to change it. We've had one key in place since the start of security. Getting the first key in there is not that hard because no one counts on it, so we're not disrupting anything. We're changing the world. But this time, we're changing what's out there. So this is the first time we've actually changed the key. So it's very kind of a big project. And I'll explain why it was a very big project later on in the talk. But we want to do this without any disruption, do it very smoothly, and that's difficult, as you know, in operations. Where we are, we've passed many major milestones. Some people think we've actually done the work by now, but we still have some more stuff to do. We still have a few more things to go, and the next phase really is the cleanup. We have to get rid of all the cruft, all of the stuff that we've left behind, so that we get rid of, we don't keep things building up into the future. And the next thing that will be visible, in January, we will start the revocation process of the key, of the old key, rather. So this is a representation of our timeline. Some of this work actually started back in 2013, but 2015 we started the formal process of studying the issue, what would it take to make this change, designing the technical steps that would go forward, and trying to figure out what were the most important things to accomplish in going through this. Oh, by the way, the timer is down to 2.5 minutes. Okay, I just want to make, okay, good. In 2016, we made our plans. We put the plans together, the operational plans, so that they would actually be very specific in what we're going to do step by step. We began talking about this because we realized communications was going to be a big deal. 2017, we did a lot of publicity, and we had planned to make a change, but we didn't. On October 11th of 2017, we decided not to go forward at that date, actually a few days earlier. And we paused for another year to do more publicity about what was going on. In October 11th of this year, 2018, we changed from the old key to the new key in terms of the active signing part of this. Coming in 2019 is the cleanup. We have to revoke the old key and get it out of our systems, make sure it never comes back to haunt us in any way, make sure everyone knows the key is gone, it's gone away. Now you'll notice that this is 5 years in the making for this project. And one thing I want to stress that it does not take 5 years to change a key. We have done two things. One is we went slow because this is a major change in the internet, unprecedented. We wanted to make sure things are all in place as we go down the road. We found there are many things that need to be fixed and adjusted outside of the normal control of the project. And two, we fit this into the way we normally run the KSK and the ZSK, the zone signing key rather, of the root zone. So we did not go out of our way to have special events for this. It just fit into the normal way we did business. And that meant every quarter of the year we could make a change. We could have done that all in a week, but we spent a quarter between each of the major changes. So Usually we have lots of things for operators to do in these talks about it's coming, do this. I boiled it down to this one slide for what operators would have to do now. And basically it comes down to this. If you've done absolutely nothing to prepare for the KSK rollover and you've seen no problems, keep doing that. You're okay. If you've been following RFC 5011's automated updates of DNSSEC trust anchors and you've had no problems, just keep doing that. Don't change what you're doing. If nothing's broken, don't fix it. Finally, though, if you have been watching this carefully and you're doing the work by hand, you don't like the automated systems, you want to do things manual configures, in January will be time to start removing the old key from your configurations, starting in January, because right now we're just making sure that we're going to go forward. There's no indication we'll ever go backward, but just to be sure. Between January 11th and March 22nd, we'll be advertising the revocation of the new key, or the old key, sorry. And at that point, just remove the key from your configuration. If you don't do that, you won't even know. You won't know that you hadn't done it. So let me talk a little bit about what made this project such a big deal and what the issues are. What's happening with this project is we have two parts to the KSK. There's a public and private key. The private key is managed through the IANA functions operator, and it's pretty easy to do that. We just have to update the key on that end, and it's pretty trivial to do that. The public key is what people around the world who want to do DNSSEC have to configure in their name servers in order to build the trust chains to validate all of the data out there. And that's a lot of work for people out there. Actually, both halves of this are pretty easy to do. The configuration of the private key, that's pretty easy. We have it in HSM, a few key clicks, we can change which key we are signing with. For anyone out there who's managing their validator, they can just update the configuration any one of a number of ways, or even have it done automatically. It's not too hard. The hardest part is getting everyone to coordinate to do this all at one time. And that coordination is all of the work here. And the coordination comes down to communication. Now, what made this communication problem special is the nature of the Internet's idea of permissionless activities, meaning that when you come to the Internet and you want to work on the Internet, you can do whatever you want. No one stops you from sending any packets you want on the Internet. And many times that's a bad thing. DDoS, people send bad, abusive traffic out there. We don't want to have that, but they can do it. We see them do it. But in general, operators who are trying to do good for the world also can do whatever they want on the Internet out there. Now, the good thing about this is that because you do what you want out there, you can innovate, you can grow, but the growth becomes very quick. If you fill everything you need to do, because you don't have to register for any action you do. You just go ahead and do it. It's great growth. The problem is that from the other end of this, no one has a record of what's going on out there. Nobody knows what everyone else is doing. So for the DNSSEC, we don't know, nobody in the world knows, all of those who are validating their DNS queries. We can't tell. We have experiments where people are trying to detect that. Is this name server doing DNSSEC validation? And the answer is a lot of times we still can't tell remotely. You can't do this without knowing more about the system. The other thing that's going on too is we don't have a way to detect this remotely. We can't snoop on things. We don't want to be doing pervasive monitoring. That's a bad thing. We don't want to be watching what people are doing. So we can't really ask folks, are you doing DNSSEC? Let me know so I can tell you these things. So this has made this a kind of a more tricky thing, because when we're trying to do the communications here, we have an unknown audience. And that's always been the hardest part here, trying to reach everybody out there. We've also had a very long-lasting project. So if over 5 years, getting people to pay attention when they need to pay attention is hard to judge. People get bored. I had one operator, when we reminded them a week before the change that we're making a change next week, make sure your systems are ready, they wrote back to me and said, oh yeah, thanks, we forgot about it. We'd heard about it, but we forgot about it, so we never updated, but now we will, because it's going to be next week. Preparing communications is difficult. You don't know who you're talking to. You don't know where they're going to be. You don't know how they want to be talked to. Some people don't want to hear a lot of uninvited operational messages out there. Different forum out there. You could spend a whole time just traveling conference to conference, but that gets kind of old for a while and it's expensive, especially. And that's why I'm glad we had Federico and Carlos to help spread the message here. One of the things I've noticed in the project is that in the early 2015 timeframe, we had a lot of experts in DNS get together and talk about how to do the role. Very, very academic, very theoretical, very high-level conceptual way of doing this. What's the nature of trust? How do we get the key out to people? It's kind of funny that as the time got closer in 2018, everyone kind of dropped the theory and went into practical. How do we just get the key out there? And one major shift was to go through all these ways of validating keys remotely to just put the keys in the DNS software that's being distributed, whether it's bind, whether it's unbound, whether it's the not resolver or Power DNS or anyone else distributing software out there. And that showed a huge shift from the theoretical to practical over time. Now, we have a technical solution to this. We have always designed the key role around the use of automated updates of DNSSEC trust anchors known as RFC 5011. This was a document from, I don't know, maybe 10 years ago, which talks about how I can put a new key online on my end, and you guys, the validators out there, can just see it and assume over time that it's a good key. But we found it works. It's a functional. It's proven to work in a few cases. I mean, a few cases meaning that we don't use it a lot, but everywhere it's been used, it seems to be behaving properly. But it has problems when you come to try to manage it. And it's great to use this to just get the keys out there, but the problem is that we've been asked, that ICANN and the IANA functions operator, was to make sure that this change will not cause disruption. And that's been an issue, because this protocol gives no feedback to how it's operating. It's not very manageable. It's secure, but it's not manageable, and it's not measurable. We tried to measure it many ways. We've had issues with that, but it's, as we've seen, in retrospect, it did its job for the most part. Actually, it did its job, but beforehand we couldn't know that it was going to do its job. We were waiting for the world to burn, and we were surprised, no smoke. So, good luck. So, adventures in measure, we tried measuring things. I mean, when you try to manage something, you've got to measure it. You have to have measurements of what you're trying to manage just to have some idea what's going on there. We tried what I call third-party testing. And third-party testing is something very familiar to the internet where you have an operator who runs a service. And the operator's job is to manage the service. But someone else thinks that they can do some testing of that remotely and say, hey, your name servers are not working right, without being part of what's going on there. And that can be tricky. I mean, you can tell sometimes whether a name server is compliant with the protocol, like in the Hugo was talking about, but sometimes you can't tell how someone's running their server. In this case, trust anchors are not data. They're not protocol, they're configuration elements. They're hidden in the configuration files. They're not accessible to remote people to see what's in there. Plus, we've also warned people, don't let your DNS be open to everybody unless you really, really want to. So anyway, we tried hard with these measurements. And there were two candidates that came up. One was from the IETF called Signaling Trust Anchor Knowledge and DNS Security Extensions. That's the formal name. RFC 8145 is the number people have thrown about it. And some people call it the key tag. And it's ironic here. I mentioned we'd like to have this years ago to someone. He said, you don't want it, it's going to be a problem. Well, he worked on it and came up with it, and it was a heartache. He was right. It was a problem for us to have this data. The data was somewhat good, but it was very misleading. In fact, the IETF is already running a second effort to come up with a new way of doing the signaling, which is still not in production, so they've already tried to fix this. To give you an idea, this is a graph of the RFC 8145 key tag data we've seen since the beginning of time. And I'm sure you've seen a lot of graphs at conferences and lots of pictures up and to the right and all stuff. This one tells me absolutely nothing. Look at this. I mean, what is it? It's a mess. What are you going to conclude from this graph? It's nothing. It's that hard. Though I will, because it's a graph, I can point at it. I will focus on something at this end down here. I notice that there's this bump and there's this dip up here. And I want to talk a little bit about those two to show you kind of the futility of relying on this data. What this data did show was the adoption of software suddenly, and then the turning on of some reporting. This green line up here is the total number of reports we see over time. And you see it peaked at some point. Red is those that we sense trouble, meaning that they're saying we only have the old key, we don't have the new key. And this black line is a percentage of the red divided by the green, basically, and it does this. It does start going down nicely here, but Still, this doesn't help me much with strategy. And to further really give you the idea that we are curious with this data, this line here corresponds with the day that we rolled the key. So on October 11th, when we put out the new signature, and October 13th, this 2-day period is significant because in those 2 days is when the TTL expired and everyone went from the old key to the new key. They had to go to the new key by then. And the percentage of those saying that they were in trouble rose sharply, which is kind of weird. And then it fell. And then, as you noticed before, the line was coming down. And so it's been on this slow, random bubbling down ever since. Now, the weird thing is, it should be at 0. This isn't getting ready for the roll. This is after the roll. Anything that's causing this percentage is not working today. It's not doing its job. It's broken. Somewhere it's broken, and no one is noticing this. So we don't really know why this is happening. As you see here, this little dip here I want to talk about, that's an example of sampling error. What happened was one of the name server operators out there reconfigured their name server's software, and for a while stopped reporting this, and then it came back. When you have a reporting mechanism where people are opting in to send data, it's very difficult to count on it. So that's another thing with the caution here. We don't know the data coming into us is meaningful because we don't know the sender really is sending it. And we have no idea why it's going down. We knew why it went up when people just put new software out there. That was great. But it's been going off, and we don't know why people would be turning this off because it's been working. And we certainly don't know why there was this rise in reports, because this is not necessarily a rise in activity, it's a rise in percentage of badness. So really difficult to work with this. What I'm trying to impress on you is we really still need to figure out how to measure this as we go forward, despite the fact that we didn't make the world burn. So why measurements, and we've tried. We had a lot of people who were very expert in the field trying to figure out how can we possibly measure this, and we came out empty. Part of this is, and I think I'm going to, so the DNS is not built to make this easy. The DNS really is meant to grow. It's meant to say that people who are using the DNS don't have to register with anyone to say they want to use the DNS data. So information from the DNS flows outward. People query the authoritative servers go to recursive servers, through forwarders down to stub resolvers. It's all one directional. If we have to know what's going on in those servers out there, we can't tell from within the protocol. The protocol just does not have that in it. So we need out-of-band ways of doing things. And so we have to start thinking that, how can I possibly manage a service when I can't ask through the protocol? And I've done decades of work of DNS testing, and the more you test it, the more you realize you really can't tell what someone else is thinking when they set up a server. So what do we do now? We're looking for alternatives, and this is not just us being the ICANN or the IANA functions operator. In the general, we have to figure out how do we manage an internet where we really have built it to be outward. People can come in and use it whenever they want. The management side of this has always been an issue. It's been growing, and I think in this case here we didn't have a problem because things worked, but we don't know why they worked as much as we don't know why they may not have worked. It's still a little scary out there. We haven't solved that. We have to change some of our expectations about the network. People, early days, the internet was you came and you worked on it and you were responsible, and now it's more of a service where, leave it to me, I'll take care of it. But that leaves responsibilities out there that some people can't handle, and that's a problem that some people see the KSK. We're managing the KSK, but we're not really managing the experience of DNSSEC, we're just managing the KSK. We don't know what people are going to configure out there, and so we have to make sure we're prepared for the right thing. And innovation is needed here. We have to change some of our coordination model out there. One of the, and I want to make sure I don't get ahead of myself in my slides, one of the things we did at the end was we did a survey of operators looking at the autonomous system numbers that sent the key tag reports to us. So there was some good in that. And we discovered in the process of doing that we were afraid we were breaking some rules because there was no clear channel where we could use to say to someone, hey, look, I've never talked to you before, but I have to tell you something important about real operations. I'm not a spammer. I'm not abuse. I'm not this. We just kind of threw away that fear and contacted people, and we got a lot of good response for that. We had very little negative comeback about saying, well, you should have contacted me. In fact, just one person said this is an abuse of our system to tell us this. But it's interesting that the coordination through the internet gets harder over time because we fear the badness out there. And one of the, I'll save this point for a little later. And the other thing, too, people keep asking us to visualize the KSK rollover better. And even after the fact, we still are sitting there, how can we make this visible? How can we make a visual out of this? The problem is that you have a resolver out there that just got a KSK configured in it, and sometimes we can't even access that resolver. We're not allowed, in some cases, to send a query into someone's ISP and say, give me information. It's reasonable. You know, if you do that, you open up for abuse if you let people come in. The open recursive servers, their job is to do that, but outside of that, there's only about 20 or so of those that are running. We can't get a whole lot of measurement out of that. So we really can't see what we want to measure, and so we can't really make it very visual. And only in cases where the resolver operator may participate in the feedback. So this is where I wanted to bring this up. So let's go beyond this project, beyond the KSK and beyond DNSSEC. Let's talk about the idea of coordinating this entirely massive system out there. One question that crossed my mind before this, and I never said it to anybody else before, is what if this doesn't work? What if we can't change the KSK? What if on October 11th, we change the KSK and within a few hours, people say, ISPs are failing all over the world, go backwards. What do we do then? The fact is we have to get off of the first KSK, the KSK from 2010. The reason is that it was made in 7 to 8 years ago. It's healthy, it's not been abused, no one's reverse engineered it. But at some point, you're going to buy equipment that can't do that math anymore. We have to get rid of it. At some point in the future, you have to get rid of it. And the longer we wait, the more pressure will be on doing it in a clean way. So I'm still scared. If we couldn't do this, the internet really is kind of hard to manage in a coordinated fashion. It won't be a very smooth event. So we have to think of a way to coordinate at a higher level everything that's going on out there. We've had the same problem for 30 years in terms of variation in code. And you don't have to run one of the 4 name servers I mentioned earlier, the bind, the unbound, not resolver, and Power DNS. There's also Microsoft. There's a few other commercial ones out there that are used all over the place. But there are people who run their own stuff, and we have no idea what that is. We've had this forever. We need to figure out a way to make this a bit more manageable if we want the internet to actually be reliable and smooth throughout the future. One of the things that has caused us to caused the internet to be a little harder to communicate is that we fear abuse so much. So many operators had in their whois records for their AS number only for abuse mail. I mean, only for mail about abuse. Don't send us spam, and so on and so forth. And we had to kind of get around a few spam filters to make sure, so the operator, you really want to make a change here because you might be in trouble, or your customers might be in trouble here. It'd be good if there was a more open way to send out an operational message across the internet in like the Flag Day too. The same thing, to keep pulling on yours because I need more material. Getting the message out to folks, really, we need to have a better way to get that out there. You know, if you come to a conference, you're already halfway there. It's the people who don't come to the conferences that I really am more afraid for. Oh, and so my final little tidbit. As I said, we did a survey in August, September, I believe, before the event of October 11. And we took all of the autonomous system numbers out there, and we tried to contact all the autonomous system members that had ever sent us any information about DNSSEC, 16,000 of them. And I was surprised by something. This is, if I take the number of AS numbers, I put a pie chart here, RIPE, the European RIR is a lot. ARIN, quite a bit too, and they're very large. LACNIC, if you look at LACNIC, it's these 2 pie slices together, the yellow and this slice here, which is LACNIC, not counting Brazil, and Brazil. Brazil alone, 18% of the world's AS numbers doing DNSSEC key tag reporting are from this one country. Now, to give you, I mean, I'm not saying Brazil, I don't expect you to be doing work, but to put this in the scale, you have APNIC is in here, in the others, which is the RIR for Asia, including Japan, which has its own NIR, like Brazil does, and AFRINIC. So all of Africa, all of Asia Pacific, they're in the other below in this region, but Brazil particularly. I said to someone, if we split the world into the 5 RIRs plus Brazil NAR, evenly divided them, they would have had the same number. Brazil's percentage matches like about 1/6, a little more than 1/6 of all of that, the 5 RIRs plus Brazil NAR. You know, it's amazing that there are so many autonomous system numbers in this one country through through NIC, the NIC.br, or NIC.br, I guess, or whatever you call the, I'm sorry, the National Internet Registry. Registry BR. Yeah. I meant sorry. But I was stunned by that. And of course, for poor Federico, what this meant was I had to send him a lot of email to get all those addresses because it was a little difficult pulling them, but that's not, so Federico had to do a lot of work to help get the message out to people in Brazil. So with that, I'm going to stop my prepared slides. I don't know how much time is for questions. Okay, no more for me? All right, so questions, thank you. Any questions?
Yeah.
Any questions, please? Yes, we have Hugo. I don't know if he will speak Portuguese or English or Spanish. Let's see. English, so you don't need me.
The DNS flag day measurements and the rollover of the KSK is that the DNS flag day is about the authoritative servers. So authoritative is supposed to be open and public, and any resolver can ask something and see what answers. But the KSK is about the resolvers that are the ones that have the key. So the resolvers are supposed to be private, and that difficult and causes all the problems that you talked. Mm-hmm.
Yeah.
Just only to make that difference.
Sure. Yeah, certainly. The many parts don't apply to both projects, but the coordination was, yeah.
Nós temos ainda tempo para alguma pergunta.
We still have time for another question.
Talk a little bit about the plans for the future afterwards. Yeah.
Oh, what a prepared question there. I'm surprised to hear you ask that. So, one thing, we've talked about this a little bit before internally, obviously. This project, we wanted to be able to do one role and get experience of doing this because we've never done this before. And this role is close to being finished. So I have kind of, well, let me put it this way. There are many things that could happen next. What will happen next is completely open. We're looking for input from the community on this. But to give you some ideas, we have things like, should we have an extra KSK in play? Should we have a backup one? Should we change the algorithm we use? Right now we're using RSA SHA-256 as the algorithm. And we just rolled from one key of that to the roll of the key of the next one and the 2048 bits length. Should we stay with that? Should we keep doing that a couple times? And also, the big question is, like, how often? In 2010, a document said that we should look at rolling the key after 5 years. And after 5 years in English has a strange way of reading that. It could be after, could mean begin looking 5 years from now, or at 5 years, make sure you've done it. But wait 5 years, but how soon? After 5 years, we began the process, so it's been almost 10 years that we've done this. So we probably should be doing this more quickly, depending on your attitude about whether operators want to have the habit of seeing this. So what I'm saying here is we have a bunch of options out there. We've looked at a couple of things, but I think it's going to matter because this key is not really a product of ICANN. It's not a product of the IANA Functions Office. It's not something we're running because we make anything off of it. It's public trust. So one thing that's going to come up is, what does the community think? People who spent more time on DNSSEC think should happen here. Because there's a lot to consider, and we're really open for input to that. However, I don't know when we plan to evaluate the input and how we're going to actually formally do that. So I'd like to dance that question that way.
Yeah, answer. Thank you. Mais alguma pergunta para o Ed?
Any other questions to Ed? As there are no more questions, thank you so much.
pessoal, continuando aqui o GTR 46.
Going on with GTER 46, let me remind you that the material is available at the server ftp.register.br/pub GTR 46. Presentations will be published and made available a little bit before we start the lecture. Our next presentation is by Frederico Neves from BR Registry and Carlos Martinez from NIC, and they will address IRPKA deployment in Latin America. Thank you. Thank you.
Bom dia, pessoal.
Good morning. I have the same problem. My Portuguese is horrible, so I will try to speak Spanish slowly. My name is Carlos Martinez. I am the technology manager for NIC. We work together with NIC.br at several projects for many, many years. I'm very happy to be here. This is the first time I make it, so thank you for the invitation. Today I'm here to talk about RPKA. Who knows about that? Who has heard about it? Let's start talking about BGP. BGP is the protocol that we use to keep internet binded, to be precise, or to have routes over the prefixes throughout routers that work among themselves. BGP is defined as a protocol based routing by rumor. When the neighbor tells you that the neighbor is going out with another guy, you know, it's a rumor, yes? Gossips, maybe. And that's how we route the internet, because there is no mechanisms between edges to inform that information or to pass that information. In this example, Internet is defined in one slide. We have two autonomous systems which they try to communicate one to another, and they have one which is closer, which is the provider router, and they believe that that provider will be very honest in propagating that rumor. Well, there is no need to go into details about BGP, right? Then they define the routes and they establish data flow. BGP is a protocol which is very complex, and the heart of BGP is within the attributes. Every time you announce it, they become rumors. They are parameters that follow for this ad. So we have to remember one of these attributes. There are so many, but let's remember about the IS path. What is the AS path? AS path, which autonomous systems ad goes through the internet passages. In this case, the announcement goes through 1, 2, 3. The first autonomous system of AS path is very interesting because we know as origin is an autonomous system which injects that in the internet. Why am I saying that? Because this is exactly what we are trying to do at the RPKA, to give some security to that origin announcement. AS path, AS origin. They are important because they allow to select the pathway to propagate an announcement. We have a path sequence, 12 of them, saying which attribute to be stated first before we decided about potential pathways. And what we will introduce as a product of the whole development of RPKA is a next step that will help us to have an additional decisional element. How about the rumors? If there is a sequestration, a malicious player, or any misleading, in Uruguay, there is a common social character which is the old lady of the neighborhood who propagates all the gossips and rumors. And she gives her own style how she propagates that information. The end product can be many. If we have a third player, third actor in this neighborhood, what happens? They put a rumor, they put an announcement, an ad, but then that can be very malicious because they may announce a part of the original block of the ASDS. I have that in red to show that he's a bad one. What happens? In the absence of other mechanisms to the internet routers, all rumors are the same. The ALS66 rumor is not worse or better than others, so they will accept like others. And what is the problem? ALS66 was not the owner of the pathways, and doing that, they will redirect part of the traffic because in fact they will correlate the traffic. S27. This type of event is known as route sequestration. That can be malicious. And the problem is in case case of Pakistan, Telecom Pakistan, you know. Is there anyone who hasn't heard about the case Pakistan Telco? Well, everyone knows, right? That was widely known. Pakistan Telecom announced to the YouTube networks throughout a internet provider. And the effect is a self-delegation of service. The problem with that, though, is that that can be malicious in a sense that they are announcing 124 more announcements, less specifics. And as that is a slash 24, they cannot use against YouTube updating the 24 prefixes. Or maybe to announce shorter things because in reality they are filtered. So here you will all note that I had simplified this, and internet accepts any announcement anyhow. The problem, though, is that those mechanisms which are implemented to control announcements are ours, or to place filters for a good practice. When you have a BGP session with a client, you put a filter, you just accept the routes that the client says yes. And I want to believe that in a manual way, those routes, they are in fact the ones. And this is quite manual. It's very difficult to be automated. And you would get surprised with the number of providers that they trust the letters of authorities, which is one PDF where he says, I have this network, and there are those who trust the value of the PDF. That is not a formed letter, but a PDF. There is a very good investigation by a Japanese investigator who says, who reconstructs a number of incidents with the fakes, with the falsified letters in China and several other countries where they use variable systems. They would send letters with rare characters which would not say anything. There was one which was a cable TV contract with Arabic digits. That was the only one to understood. At this level, they announced the routes at the internet, and that is quite difficult. And when you have the large carriers, tier 1, so many networks have to be checked, and sometimes that is not possible. And then they have a more automatic mechanism for that. There are more formal mechanisms to do it. What can we do about that? In fact, there are two actions to be taken. Let's say that there is no extreme mechanism. That's true. First, as internet users, I haven't got any mechanisms to announce or to tell to the world that these are my networks. This is a mechanism where each operator at the internet says, well, these are my networks. These are my networks, and I will announce that autonomous system. The origin of that will be the autonomous system. And describing that, and describing the system, what we have is a database called repository, and that has a type of server where all micro contracts are present. Those mini contracts, we call them routers, ROV. Why is this APKI? That is a row of IPKA with certificates, and that gives authorities. But for the effects of the routers, they are separated by origins. What happens between the PKI and the pointer? That is an element known as cache. A cache is an element which is not in the router, where we'll have 2 or 3 per ROV. When you go down with the repository and produces that for the route. What happens once the routers get the announcements? They will apply the same BGP, and they will compare that to that database from the repository. They know that as origin validation, and the BGP feature implemented. We have to validate the origin of the announcements and also provide a cache so the router can feed from repositories. What happens? They compare that to that database that says about prefix and origins, and they will sign what is a validated state, which is a BGP attribute. After, I will be able to use that in my router maps to take decisions. The valid states, we have valid, invalid, and unknown. The words are overloaded. They are emotional words. People believe that by being invalid, they will be discarded by the router. But that's not quite the configuration. By default is that they do not do anything. They just validate. They mark the prefix with the state of validity. If I want to do that, they have to mark that with a line. one can say that automatically they will discard the invalid ones. If there is a announcement and if they find the correct one, that will be valid. If they find the contradictions, if they find that prefix in that database in the cache, but if something that does not coincide, that will be an invalid one. And if I don't find it, they will be unknown. If it's unknown, I cannot say anything about that. There is a great discussion when people will discard that or not, but it will take quite a while. Some organizations in the organizations, they are discarding the invalids. This is the KPI, no further mystery. All structures are certified. There is no mystery. The only thing different here in this RPKI is that the certificates, they have extensions which are not present, and some directions for IP and autonomous systems. And to close, let me share some successful regional experiences. That is the first one, NAP Ecuador. NAP Ecuador was one of the first ones in the world where RPKI and origin validation was used for production. That is a Kappa 3 with a router server, and they went after validation in the router server to know if that was stable, if it would not generate any problem. And they advanced, and finally they reached some discussions, and that was presented as a consensus by that community, and they decided that they would mark with communities those state of validity in a roadmap. If that is valid, they apply in a certain unit, and so on and so forth. And they tell communities what that is. After, what to do with those routes, this is a decision by each one of the team members. It sounds very interesting. That was my first experience, and they have been doing that for almost 5 years. That is a pre-request for new members to accept that community, for instance, and to form and create roles and authentications. Some more recent cases, CRIX, Costa Rica, .CR operators. They gave a step ahead from navigator standpoint, and they decided to do drops to discard the invalids at the router services. Operators decided to do that. They also have been through a phase of communities, and then they decided to do the discard. Renata in Colombia, an academic network, a large net. They are under the first stages of implementation, and they will go through the pathway of NAP Ecuador. And yesterday, talking to Hugo, I heard that Pete, Chile, are effectively implementing RPKI in their setting. Some statistics. This is the coverage of affirmed step in IPv4. The thing is to count the amount of IPv4, and then I fix how many of them will be covered by a role which validates them or invalidates them, and how they are protected. And then I ponderate that, and they will say that there are countries with very high coverage, because of two reasons. The higher one is from Ecuador, where all operators are present in AP Ecuador. Somehow, they are obliged to do it. And after several countries where there is a dominant operator, such as in Uruguay and in Costa Rica. There are so many countries with the high coverages, so above 50%. How many? How many of them? The problem, though, is that in general they are small countries in South America. China and India, they are in black. I don't know, I think it was a copy-paste error only. And this red in the US happens because there is a pair of prefix like NIC, which is an artifact of the migration of Arena like NIC. The percentage is quite bad because comparing to all others, that's almost nothing. Countries in green, they have 100% and they are represented the smaller countries. With that, I conclude my presentation.
Bom dia, pessoal. Eu vou falar pouquinho sobre RPKI no Brasil.
Good morning. I'm going to talk about RPKI in Brazil. I have mentioned some of that at the GTER list. RPKI support in the country that is integrated to activities performed in Chile, like PTI in Chile, IX in Brazil. We are deciding about invalid ones. RPKI is a medium to long run action because there is no support in the Brazilian NIR. And now I will share what we are doing to solve that. As to our interface of numbering, we are quite advanced, and that will allow better usability, DNSSEC support. Regions, they supported that for quite a while, but today we cannot collect DS throughout PP protocol to LACNIC, but that is being implemented, and it is one of the first things that will be working, and the same interface will be prepared for RPKI. We'll have conditions to do provisioning in a delegated or hosted situation in the future, that it will be in operation before the next GTER. As to RPKI, what is the software to be used? RPKI tools that is under development by NEL Net Labs, that is being supported by NIC.br and by RIPE CC. This URL, you can get information about the project, development plan, and roadmap for the software. The first version in the roadmap will happen next December, which is aligned to those dates of when we will introduce the service in the BR point. There are two modes of operation. One of them is the delegated one, which works via a provisional protocol, up-down protocol defined in the RFC. The first institution to use that operational model was APNIC. They also have NIRs. Such a protocol is a simple one of SMS messages encoded in XMLs about HTTP. There is nothing exceptional about that. Authentication to the protocol is usually set up out of band. The other operational model is the hosted one, where you delegate to third parties the control of the cryptographic material, rows, and so on, via web interface. LACNIC does that to some customers in the region. Delegated CA, that's how we start working in .br. Authentication will be configured by the numbering interface, which will be prepared for that. We also implement right away a monitoring system and alert for invalid rows. Rows are OAs, right? DNS delegation, DNSSEC delegation, where we constantly monitor and report it. When we make RPKA available, that will be no different. We'll keep on monitoring it and to keep that in a directory system to publish that, and we'll also notify if there is invalid addresses. Beta in coordination with LACNIC will take place next September. That depends on LACNIC and NIC.br development, which is implementing the up-down protocols. And we hope to have that system under production by the end of next year. And we're planning to have RPKI tutorials during this event. This then was the first step. Second, RPKA with the hosted cells. What is a delegated one? Those who would like to use RPKI from the very beginning will need to have one installed. They will have to manage their cryptographic material, and they will have to do that. We hope that to happen in the second semester, where we'll have a model in a subordinated CA and a host of that cryptographic material to clients. And ROAS will be issued by the numbering interface. That depends on multi-CA RPKA tools. And production will be on 2020, second semester. That's it, guys, for now. And I think we still have some time for questions addressing either this deployment or RPKI in general. Carlos and myself can try to answer to your questions. Thank you.
Perguntas, pessoal? Douglas.
Questions? Fred, you mentioned that we will have the delegated mode and the hosted one. To the delegated mode, to do some time of automation, to generate ROAS, ROAS, that it's easier, but it's quite a responsibility. In the more coherent one mode, the delegated one, the automation is web interface. And I guess that within that context, you forecast some sort of interface allowing automation, API, I don't know, or some other tool. And that's exactly my question. Those with received the resources, they'll be able to manipulate those delegations and RPKI delegations and ROA throughout some automation. I did not describe, but in the RPKI tools you can get much information. The first software version makes available two interfaces. One interface to talk to other CAs, that is the up-down protocol, but there is an interface in web service to generate and to manage that system. And NIC.br will talk to that CA installed to our system, and there will be a web interface. If someone first can just use the delegated mode, they can have a web interface to manage their roles, and also there will be a web service interface to automate that CA, but still they'll have to host that encrypted material and that CA internally. When the software support multiple CAs, we'll have a second one, NIC.br, where we can host the service and exclusively with a web interface, at least in the first moment we are willing to do it. If we have a web service available or not in the future, well, just the future will tell us. Well, but anyhow, for those that would like to automate it, CA is the best one. Our effort and the RIPE in CC to help the N labs to develop softwares, it's because unfortunately we have a small amount of free software available for RPKA. We have RIPE implementations, and we have what has been done in the United States of the robousting, about robousting. And the quality of the existing software, the effort of Net Labs is that this implementation, known as RPKI tools, would be of excellent quality as the whole software. That will be very simple to run within the ISPs. I have a comment. In Rosario, I participated at a lecture in Rosario, and they mentioned that at LACNIC there are 12,000 prefixes, 2,000 invalid ROAs, and unfortunately Brazil so far has not an available infrastructure. Regarding to keep talking about training, we are starting from zero. We are fresh. And we see people generating certificates in the gold ads, and they make it wrong. Come on. So training has to be endless. I guess that this integration is a good idea, but that is a request that I make regarding training, more training, exhaustively training. So as there are no more questions, let's thank... I'd like to make a comment about invalids. ROAs are not invalids; they are valids. What we have are invalid routes. And I have an additional comment, which is routers. The LACNIC region is the region with more invalid routers. And when you analyze those invalid routers, you see that almost all of them have a valid route less specific than others. So if I decided to discard them as invalid, there is no connectivity loss. And I have a more optimistic view about the invalid rows. We always keep complaining about disaggregation. And now I ask myself, couldn't that mechanism work as someone that will help to deal with those more specific routes? We all know that we could use the expert communities, but not we do not use that as we could. Out of those 2,000 invalids, 1,500 of them are generated by one single organization, which I prefer not to mention here. So invalid routes that we see in the internet, they are the most specific ones routers, which they shouldn't exist because they do not care about anything else, right? Yes, I agree. Thank you for your comment and answer. Hi, my name is Victor. I have a question to both of you. It was said here, it was mentioned about communities to mark valid versus invalid routes. But there are ways to stimulate the adoption of RPKI? I've heard or I've read somewhere. Well, he is rephrasing his question, I suppose. You've talked about communities, routers, map. He forgot his question. He lost his thought. I'll try to remember what my question was. Well, during the coffee break, I reach you. I'll try to remember my question. I remember now. I'm sorry. There is a decision algorithm for the best ways of BGP, which analyzes the attributes. RPKI could be used as a way to decide for the best route. Who's got the preference? Have you heard about anything like that on draft or RFC or something like that? I think that's what he meant. Yeah, that's exactly an attribute and an additional step of the decision agreement when the RPKI is skilled at the router. When you have a roadmap, what you are doing, you are evaluating preferences. The validity test or status is an additional checking. The community tools is a way to motivate RPKA deployment. The software images of those routers which support origin validation maybe is not the one that most operators are running after. And in some cases, they may request memory or hardware or some router of some brand that does not support it. The tools communities to express the RPKI where all router that opens BGP RPKI will understand. This is a way to foster the origin option, translating that information to something where some BGP can validate communities by routers. This is a way to make that more accessible. So you mean those communities, they would be marked as a bogon, they would be discarded or less preferred? Well, it depends on your policy as operator. You can do whatever you feel like, you can discard, you can propagate, you can mark them again. That depends and varies from case by case. Okay, thank you. I have a brief comment about your question. Attributes in BGP choice does not solve one of the problems, which is to announce more specific prefixes, but invalid ones. Those specific ones, they will win from those more comprehensive, regardless of the BGP choice. So we still have some issues to consider, which does not just involve a BGP algorithm. We have to see that from a broader perspective. So a big round of applause to our presenters. Thank you so much. We are running a little bit late, so please be back at 11:10. We'll have to reduce our coffee break to recover the time we lost. Thank you. Translation is over now.